Hello, welcome to a video on stacks. In my last video, I went over what a stack is and some pretty basic things about it. So what methods it has, what it's used for in a very broad sense, and how to sort of visualize it. Now in this video, I'm going to be using Python to actually implement a stack, which is something you will never really need to do if you're working in the field. But it's really nice to get sort of how the inner workings of a stack are, as well as for any other data structure. So quickly I'll go over some use cases for a stack. Oftentimes you'll use stacks for anything that has to store like previous decisions or previous data and have the ability to go back and forth. So one example of that would be back and forth arrows in the browser or in an application. It's also commonly used for redo and undo, so Control Z, Control Y. The use case we're going to be testing it with is delimiter checking. So if you've ever used a compiler, you'll know that you often will get a warning if your brackets don't match up. Stacks are perfect for doing that. So down here, if you check out all these strings, you'll see there's a series of open brackets and a series of closed brackets. Now with a stack, we can easily push the first element in, and then in the following closing brackets, we can check whether the element that's popped is the opening bracket for the one coming up. So if you imagine we have a stack, we could push an open bracket, push an open bracket, push an open bracket, and then we encounter a closed bracket. We'll pop the last element off the top, make sure it matches, pop the last element off the top, make sure it matches, and so on. So that's what we're going to be testing our stack with. Let's get to it. So these are all the methods in the stack that we're going to be creating. I went over them in the previous video. There should be a little button in the top right now or previously in the video if you want to go watch that one to get a bit of an intro into it. And if you already know what a stack is in a broad sense, this video is perfect for you. So first of all, we have our stack class and we have our constructor. Now our constructor for a stack is very, very simple. In this case, we're going to be using a list to back the stack. So you always need some sort of way of storing your elements in a stack or any data structure. In this case, we're going to be using a list. In the link stack over here, we're going to be making it like a linked list. But first, for this guy, we're going to set up our elements. So self.elements equals an empty list. And we'll set our capacity equals capacity. Now, I've set the capacity to optional, defaults to none, because you don't really need a capacity for a stack. You could just have it grow and grow and grow until you run out of memory, which is one of the options here. So now for the simplest option, or the simplest methods or properties, we'll do isEmpty and isFull. So isEmpty, very simple. You're simply going to return whether the length of your elements, self.elements, is 0. That means that nothing has been added to it. We have an empty list. Now for isFull, we're going to say return capacity self.capacity is not none, and the length of the elements is greater than or equal to self.capacity. Now, realistically, we could probably just say the length of the elements is equal to the capacity, because there should never be a case where push increases the size of elements above capacity, as you'll see later on. But just in case someone comes in and directly alters the capacity, directly alters the elements list, we want to check whether it's greater than or equal to, because it doesn't really cost us anything. Now, let's do push next. So for push and pop, there are some cases that need to be met, or some preconditions that need to be met before you call them. So for push, we need to make sure that the stack is not full yet, because if it's full and we push, then it's going to overflow, and that's where you get a stack overflow error. And for pop, we need to make sure that the stack is not empty, because then you get a stack underflow error. So finally, we also have some post conditions. So at the very end, the stack should have one less element, or to have one more element. Pretty straightforward. And for pop, stack should have one less element. So Here, we can very easily check if self dot is full. Self dot is full. Then we're going to raise, is there a Stack Overflow? No, we're just going to raise a runtime error, and we're going to say Stack Overflow. Easy as that. So now we're guarded against Stack Overflow, and then we'll say self.elements.append element. And that is our, oops, we do not need a semicolon here. And then there we have it. You have your push. If it's full, it'll throw, raise, I should say. And if not, it'll go ahead and add the element. Now for pop, it's very simple. We're going to say if self.isEmpty, raise runtime error again, stack underflow. Just kind of a funny little thing there, stack underflow. And then real easy, because elements, because a list in Python works sort of similarly to a stack, we can simply just return self.elements.pop. And that's it. So now you have your stack. Now in our use case, we can check whether our stack is working. And down here, we should see the first one should pass. The second one should also pass. The third should also pass because these are closed and these are both closed. But the third one should fail. So now if we run, we see function A, no close bracket here. Not all brackets were closed. Perfect. So that's our stack. If you want to take another look, here it is. Boom. And onto the link stack. So now, really they should say linked, but that's okay. So if you're not familiar with a linked list, maybe go look that up first, or if I have a video, maybe I'll link it, or just check my account to see if I have a video on linked list yet. But the premise is, instead of having an array backing your data structure, you basically have these little nodes. So you have a node here with an element inside, and this node holds a reference to the next node. So it's super easy to go sequentially through all the nodes and get the next one until it's pointing at none. Wow. So that's the sort of premise around it. Here we have our node class. We just have our element and the next reference. It starts off as none because if you have a node, the very first node is not going to have any reference to a next. And then our has next is just checking whether self.next is not none. All makes sense. So here we have our constructor. It's basically the same thing as our last one. But instead of storing elements, we're going to store top. Self.top equals none. So right now we have no elements. And because of that, we're just going to store none as our top. So there we go. And we're going to store our optional capacity. Equals capacity. And there are some benefits and cons, or pros and cons to a linked stack, but I'll get into those in a minute. So now our isEmpty is going to be extremely easy. We'll just say return self.top is none. There we go. IsFull is a bit more complicated. I'll get into that in a minute. So let's go back over here to push. And push, we still have the precondition of if self.isFull, then we're going to raise a runtime error, and we're going to say stack overflow. Easy as that. And we might as well go over here and set our condition isEmpty for pop. Runtime error, stack underflow. And for peak, I actually forgot to do peak in the other stack. I'll go back and do it at the very end, but the preconditions for peak are that we are not empty. Because if they're empty, there's nothing to peak. So we're going to raise our runtime error. Stack cannot peak on an empty stack. Since a stack underflow doesn't totally make sense to me for peak. Now, for push, the process is fairly simple to add a new element to our chain. So first of all, we're going to create a new node. So next is going to be a node whose element is the element that was just passed. And it looks like we can't actually access the node, so we're going to move him out of here. And there we go. So we're going to make our next element, and then we're going to check whether top is already a node. So if self.top is none, we'll do something. Otherwise, we'll do something else. So if top is none, then that means that this is the very first node. So we're going to set self.top to next. Fairly simple. If top is not none, it means that the new top should still be next, but next should hold a reference to the current top. So if you imagine our stack over here, this is our top. If we're going to add another element to this stack, we want it to be the top so that our peak and pop will take this guy out. But if we don't hold a reference to this guy, then he's just going to get removed by the garbage collector. So we'll set our new element to top and our previous top to next. And that goes the current top, next dot next is equal to the current top. And then we change our top to next. A bit confusing, but hopefully the graphic helped you out. Now for pop, also fairly simple. So we already know that we're not empty, which means that top is not none. So that means that we want to take our top. So top equals self.top. And we want to remove it from the stack. So now at the very end, we're going to return top. So we have that all set. But right now, we're not actually changing what our stack is holding. So just like in our picture here, we want to remove our top and now set our old guy back to top. Right? So we have our top right now. He's holding a reference to next. We want to set next to be the current top and then return this guy. So the way we do that is we're going to say self.top.next is equal to top. Oh, I'm sorry, that's not true. Self.top is equal to top.next. So our new top is equal to our current second element. And this is nice because if top.next is none, then we're going to go back to our perfect is empty use case, or our is empty case, where top is none. Perfect. And then we're going to return top like we said. Now, peak is pretty much the same thing. Well, actually, it's much simpler. We're just going to return self.top. And you know what? I've actually been lying to you. Here, we're going to return top.element because we don't want to return the whole node. We want to return the element itself that's being stored inside of it. Yes. And now for isFull, slightly more complicated than the other isFull. Actually, much more complicated, but still not too bad. To do it, we're going to make a little bit of a helper. So here we're going to add a private property called size, and this will return the size of our current stack. So to do that, we're going to say if self.is is empty, we're going to return 0. Otherwise, we're going to say that the size is 1 because we know that we for sure have one element, or one node, I should say. And then we're going to say we're going to store the current node that we're looking at, and that's going to start off as our top. Then we're going to say while our current element has a next element, current is current.next, and our size is going to increment by 1. And then we're going to return our size. I'll explain this in a second. And then finally, our isFull is just going to return whether self.size is equal to, or sorry, is greater than or equal to our capacity. And also that self.capacity is not none. So now what this is doing is we're getting our, let's say we have a little chain here. We're going to take our top. We're going to set it as our current. and our size is going to be 1. Then we're going to say current.next. If it exists, set this guy to current and increment our counter. Check again, set him to current, increment our counter. Check again. Oh, it's none. And we're not going to increment our counter, so we're going to return 3. And that's how this works. So now, if all goes well, we should be able to import from linked list, or link stack, import link stack. We'll replace our stack here with a link stack. And hopefully everything here should work fine. See, we have function A, open bracket, boom, now all brackets were closed, just like before. So easy as that, that's how you implement a stack. And I'll show quickly how to do peek. Any, fairly straightforward, just like the other one. We're gonna say here, if it's empty, cannot peek on empty stack. And instead of popping, we're just gonna get the -1th element. And it's easy as that. Hopefully this was informative. Hopefully it helped. If you have any questions, leave them in the comments below. Go ahead, like, subscribe, and yeah, thanks. See ya.